All right, we're going to go ahead and talk about laws of cosine. To find the law of cosine, we have this equation here you have on the book. Again, we use laws of sine and cosine to find missing side and angles if they're not right triangles. So this applies to other types of triangles, not right triangles. Here, we have the opposite side. Let's say for the cosine here, we're focusing on the angle A. So the opposite side, so lowercase a squared, is equal to the two included sides of that angle. So b squared plus c squared minus 2 times, and again, b times c, so the included sides, times the cosine of the angle. So to find the opposite side, we would have to use this formula here. And then to find angles, we always resort back to the law of sine, which is setting them equal to. So the angle over the opposite side, the angle over the opposite side, etc., etc. Example 1, we need to solve for all the missing sides here. So we have to look and see what we need. The first thing we're going to do is solve for s. So we need to solve for s, for r, and for t. So for s, I know it's across from capital S. So that means to find s squared, it's equal to your other two sides squared. So here, since we're looking for s squared, it's one of your sides squared, it doesn't matter which order, plus your other side squared, minus 2 times BC, so that means 2 times that same numbers again, so 13 and 17, and then multiplying it by the cosine of that main angle that we're focusing on, and that is 75 degrees. And then we go ahead and go step by step and solve for it. 13 squared is 169. 17 squared is 289. 2 times 13 times 17 is 442. So minus 442 times the cosine of 75. And go step by step by adding them. I'm going to add these two, and I get 458 minus 442 times cosine of 75. I kind of just did it together so I can just make it faster. And when I did 442 times the cosine of 75, I ended up with minus 114 minus 39. So the s squared, go ahead and subtract those two. I get 343.61. Again, it's s squared. We have to find the original, and that would be about 18.5. I'm going to round to the tens. There. So then s here is 18.5. We found what one of the sides is. Now we have to find the angles. Let's go ahead and focus on angle R. So finding the angles, we use the regular law of sine. So angle R. So we know it's the sine of R over the opposite side, which is 17, is equal to, you need to find one of the side angle pairs that have both of them. And that's, in this case, only s. So the sine of s, which is 75, over the opposite side, which is 18.5. All right, sorry about that. I cross multiply. So I have sine of r is equal to 17 times the sine of 75. And it's 18.5 times the sine of r. Divide 18.5 to both sides, and I'm just going to rush through this. Sine of r is equal to where did I have it? I just had it. 8876. And then to find the angle, you're going to do the inverse sine to both sides. So when you do the inverse sine, you get r by itself. So the inverse sine of 0.8876, you end up with about, I'm just rounding, 63 degrees. So again, it's just rounding. And then from the last step is, here we have to find this last angle. You could use the law of sine again, but what we remember is the 3 angles inside a triangle equals 180. So that means 63 plus 75 plus x, which is the angle t, is equal to 180. And then when you do that, you end up with 42 as your last one. And again, you're rounding, so if you're off by 1 or 2 degrees, that's fine. So then your last one will be 42 degrees. Let's go on to the next one, example 2. Now, we can't use the law of sine to solve for this because here we don't have any angle given to us. we have to go ahead and find the angle ourselves. So if there's no angles that's given to us, we have to apply the law of cosine. So here we're focusing on C. So now we're going to create an equation to find what C is. So I'm going to use this space here. So now we know that the opposite side squared, so it's 21 squared, is equal to the included side of that angle. So included side, which is 18 squared plus 12 squared, minus 2 times the included side of that C, which is 18 times 12, times the cosine of the angle, and we don't have anything, that's why I'm just going to put as C. So we're going to be focusing on angles whenever you're doing these type of problems. Now, you go ahead and do step by step to solve for them. 21 squared is 441, equals 18 squared is 468, 12 squared is 144, 2 times 18 times 12 is 432, cosine is just cosine of C. Step by step again, 441 plus, if you add these two together, you end up with, I didn't add them, 468. Oh. Okay. Thank you, Joe. Okay, so I skipped that step over there. So I did 18 squared plus 12 squared. I added them together, and that's how I got the 468. So I was really skipping steps to save time. 432 cosine of C. So 18 squared plus 12 squared, added together, I get 468. Minus, multiplying this, I got negative 432 cosine C. And what we're trying to do is get the cosine of C, basically the C by itself. Now, we go ahead and subtract 468 to both sides. This cancels out here. I have negative 432 times the cosine of C. 441 minus 468, I get negative 27. And then to get the cosine by itself, I divide both sides by negative 432. And then I get cosine of C is equal to a decimal, which is 0.0625, and multiply it by the inverse cosine to both sides to officially get that C by itself. And I get about 86.4 degrees. So it's just going step by step. I just do a lot of multi-step, do a lot of things at once. So it's just easier to just solve for them. Instead of having a whole thing, because you can't have a whole page of just work if you go step by step. But just, again, keep in mind of all your steps. B. So here they have a problem. They didn't show you a diagram, but to help you to draw these, I drew out the triangle DEF. Here, whenever they said lowercase d, a lowercase e and lowercase f, they're always across from the capital D and E and F. So lowercase d is across from the angle D itself. So here I labeled it according to what they gave us, and now they're asking us to find the measure of angle D. So we're focusing on this here. So now we go back and use a law of cosine. So that means the opposite side squared is equal to the included side squared. So that's 48 squared plus 14 squared minus 2 times the same included side, 14, times the cosine. In this case, it's a cosine of D. Now, go step by step. 60 squared is 3,600. 48 squared plus 14 squared is 2,500. Minus 2 times 48 times 14 is 1,344 times the cosine of D. So again, just skipped a couple steps just to keep it going. Here we want to get the cosine of D by itself, so go ahead and subtract both sides by the 2,500. You get 1,100 is equal to negative 1,344 cosine of D. Divide both sides by the negative 1,344 to officially get that cosine by itself. And I end up with negative 0.8184. After that, you're trying to get the D by itself, so if you multiply both sides by the inverse cosine, and then your angle D is equal to 144.9 degrees. So we're not looking for anything else, just for that one angle. So just go step by step. The book has the equation for you. Last part of this is the Heron's formula. So when you're trying to find areas of a triangle, most of the time the triangle, especially in geometry, they dealt with right angles. So here there's no way we can create a right angle. It's just a random triangle that we need to find. So to find the area, we use Heron's formula. According to this, the area is equal to the square root of s times s minus a, that means one of the sides, times s minus b, the other side, times s minus c, the last side. And to find what your s is, and you're going to have to find that first, is 1/2 plus the sum of these sides there. So now, to find s, so example 3, we have this triangle here. We're going to find the area using Heron's formula. We have to find what the s is. So 1/2 times the sum of the sides. So 9 plus 11 plus 18. My marker is running out. And now, we end up with s being 19. Now, we go ahead and apply the formula. Area is equal to s, that's 19, times 19 minus the first side, I'm just going to focus on this here, times 19 again, the s minus the second side, times s minus the third side. I end up with that. Now, we go ahead and simplify it. So the square root, always bring that square root, 19 times 10, 19 times 8, and here we have 19 times 1. So when we multiply all those three numbers together, so just going step by step, and in the end you're multiplying it all out, you end up with 1,520. And then, again, keep on going, you get about 39. So it's about a 39 units squared for the area of that triangle using the Heron's formula. If you guys need more help, make sure to email me down there. I have my email address there. Have a good day.